Counterexamples. Our objective in this lesson is to be able to provide counterexamples for false statements. We will be using inductive reasoning. Inductive reasoning is the process of drawing conclusions from a limited set of observations. Observations are things that we notice. We use observations to look for patterns. From those observations and the patterns, we make conjectures. A conjecture is a guess. So when we make conjectures, we make guesses based on the observations. We can use counterexamples in case the conjecture is false. A conjecture is an unproven statement based on observations. Remember that we said a conjecture is a guess. If the conjecture is false, we can provide a counterexample. A counterexample is a specific case. Keep in mind, it must be specific. A specific case for which the conjecture is false. When making a counterexample, assume the premise or the hypothesis is true. Let's take a look at this example of an inductive reasoning. Julie notices that the floor in each of her 8 classrooms at school has square tiling. She concludes that all the floors in the school have square tiling. So, Julie notices something. What are the observations? The observations is what she's noticing. She notices that the floor in each of her 8 classrooms at school has square tiling. Those are the observations. The floor in her classrooms have square tiling. What is the conjecture? The conjecture is the guess she makes based on what she has noticed. So she concludes with her conjecture that all of the floors in the school have square tiling. Is this a true statement? Well, think about our school. Is everywhere in the school with a floor that has square tiles on it? No, it's not. I can think of a place. Can you? How about the auditorium? The auditorium is a classroom in our school, and it does not have square tiling. It has carpet. So remember, we were supposed to assume that the premise is true, that it is a room in the school. The auditorium is going to be a specific example of one of the rooms in the school. The auditorium has carpet. So it is a room in the school, but it does not have square tiling. It has carpet instead of square tiling. So do you see how inductive reasoning works? Let's take a look at some more examples. We're going to show the conjecture is false by writing a counterexample. Remember, a counterexample is a specific case. First one, any two-legged animal is a human. So we want to think of a two-legged animal that is not a human. Often it's easier to think of this as an if-then statement before we write a counterexample. So remember how we do that. We look for the verb, is, the action word. That's where we split the sentence. If, the hypothesis is before the verb. Any two-legged animal. So, if an animal has 2 legs, then it is a human. So remember that we're supposed to assume that the premise is true. So we need to think of an animal that has two legs. Start there. Then it can't be a human. That would be a counterexample. Can you think of an animal that has two legs only? I can. So our counterexample would be a kangaroo. A kangaroo has two legs but is not a human. Sometimes it's easy to visualize the relationship between the hypothesis and the conclusion in a Venn diagram. You remember Venn diagrams. I'm going to draw one. Putting the larger group in the outside box. So we've got two-legged animals. Some of them are human. So the bigger group is the hypothesis. Two-leg animals. Inside the group is a smaller group of humans. But can we think of other two-legged animals? Of course we can. Remember I said kangaroos? Kangaroos are two-legged, but they are not humans. So kangaroo is a counterexample. If you can find something that's in this group of the hypothesis, but not in this group of the conclusion, then you've found a counterexample. Let's take a look at another one. No quadrilaterals have congruent sides. Let's start by making this into an if-then statement. Where's the verb? Have. Let's split the sentence there. No quadrilaterals have congruent sides. So first part has to be about being a quadrilateral. So we can say if it's a quadrilateral, then, now it says no quadrilateral. So we're going to say it does not have congruent sides. Then it does not have congruent. I'm going to use the symbol for congruent sides. If it's a quadrilateral, then it does not have congruent sides. Can we think of quadrilaterals, four-sided figures that do have congruent sides? Let's draw a Venn diagram. We've got quadrilaterals. I'm going to call them quads for short. We've got a group that has no congruent sides. Can we think of quadrilaterals that do have congruent sides? We sure can. How about a square? Squares have congruent sides. So our counterexample is something that is a quadrilateral. It has four sides, but it does have congruent sides. So a square is a counterexample. Let's look at the last one. Perhaps you pause the video, try it on your own, and come back and see how you did. All triangles are equilateral. Here's the hypothesis. If it's a triangle, I'm going to use the symbol for triangle, then it's equilateral. Well, equilateral means all the sides are congruent. Can we think of a triangle that is not equilateral? Maybe we make a Venn diagram. We've got a group of triangles. These are all the triangles. Inside the group, we've got a type of triangle where all the sides are equal. I'm going to put congruent in there because equal sides means congruent sides. Can we think of a type of triangle? It has to be a triangle, but it's not equilateral. We sure can. How about scalene triangles? Those do not have any congruent sides. So our counterexample, I'm going to write counter for short, is a scalene triangle. That is a triangle that is not equilateral. Thanks for watching.